Here, and today we're going to be working on Unit 7, Notes 5. So we are going to be talking about independent and dependent events. So let's go ahead and let's just start taking a look at some probabilities and where we're going to be kind of using this concept. So first thing we're going to start with is talking about a fair cube. So a fair cube is rolled. So it has numbers 1, 2, 3, 4, 5, and 6. So we want to find the probability of rolling a 2. Well, to find the probability of rolling a 2, we know we want to do our successes over our total. We know there's 1, 2 out of a total of 6. So 1 divided by 6 is 0.167. So that's the probability of rolling a 2. Now I want to find the probability of rolling an even. So there's 2, 4, and 6. So there's 3 evens on a dice out of 6 total. 3 divided by 6 is 0.5. Then, taking a look to figure out how many prime there are. Now, remember that 2 is a prime number. And then we have 3 as a prime number and 5. So 3 out of the 6 are prime numbers. So that's going to be 0.5. So that's a lot what we did on our previous note sheet. So let's go ahead and let's take a look at this next one. So now we kind of have 2 events going on. So we want to find the probability of rolling 2 4s. Now, we're rolling the dice twice. So the first time I roll it, there's a 1 in 6 chance that I roll a 4. Okay? Now, the second time I roll it, it doesn't matter what I did on the previous roll. If you really think about it, yes, I just roll a 4, but I'm still equally as likely to roll a 4 again. So it's going to be 1 over 6 yet again. So now we're going to multiply. 1 times 1 is 1, and then 6 times 6 is 36. Okay, when you multiply fractions, you multiply both the top and the bottom. So then I get 136, which is 0.02, and then 8. So that right there is your first probability. Let's take a look at letter B, the probability of rolling a 2 and then a 3. So then we have 1 out of 6, because there's only a probability of getting 1 out of the 6. Okay? Then the probability of getting a 3, well, there's only 1 3 out of the total of 6. Okay? So now, again, I'm going to multiply across the top 1 times 1, and then on the bottom 6 times 6 is 36. So divide that out, and again, I get 0.208. So for the next one, I want to figure out the probability of getting 1 and then any number. So our success for getting a 1 is 1 out of the total 6. Then, getting any number, all of my numbers on the dice are going to be a success. So that's going to be 6 over 6. Okay, so now we're going to multiply across the top. So we're going to do 6, and then we're going to do 6 times 6 on the bottom, which is 36. So 6 divided by 36 is 0.167. Now, really, when I did it in my calculator, it's 0.16666666666 and so forth. You really want to make sure you're watching your rounding. If the fourth number is 5 or greater, remember that you need to round that up. Okay? So let's talk a little bit about probability. Now, we briefly talked about how probability is the number of successful outcomes over the possible of outcomes. So the probability of rolling a 4 is written this way. The probability of rolling a 4. We have our 1 success over our 6 total possibilities. So let's talk about independent events. So when we're doing independent events, the result of one event has no impact on the result of the second event. So they don't affect each other at all. So when we were talking about rolling a dice, that was an independent event. So another one would be rolling a dice and drawing a card. Okay? Those two are two separate things. They don't affect each other. Now, the difference is a dependent event. The dependent event is when the result of the first will impact the result of the second event. So, for example, if you draw an ace and then you're going to draw another card, but you don't put the ace back in, well, that's going to affect the total number of cards that you have in the deck. So then that way, the two of them are related, and they do impact each other. So those are dependent events. So now let's go ahead and let's take a look at independent versus dependent events. So for the first one, choosing the color and size of a pair of shoes. Is the size I choose going to affect the color? Hopefully not. If you order online, you can usually get everything, right? So those two things are really independent of each other. Okay, those two things are independent. So the next one, choosing the winner and a runner-up at a dog show. Well, think of it this way. Once you choose the winner, there's one less person for you to choose for the second place. So that one is dependent because one affects the other. Once you choose the winner, the second place person is a lot harder to track down. The next one is choosing a president, vice president, secretary, and treasurer for student council, assuming that people can only hold one position. Well, if you think about it, if first you choose the president, then you have one less person that's able to be the vice president. So that's dependent because once you choose one, it could affect the other. Last but not least, a selection of a fiction book and a nonfiction book. Well, if I take out a fiction book, that's not going to affect the collection of nonfiction books at all. So that one is going to be an independent event. Okay? So let's take a look at applying some of these. So at a picnic, Julio reaches into an ice-filled cooler containing 8 regular and 5 soft drinks. He removes a can and then decides that he's not really thirsty. What is the probability that Julio and the next person reach in the cooler and both randomly select a regular soft drink? Well, first of all, here's one really big word indicator right here. Puts it back. If it puts it back, that means the total staying the same. Put it back or replacing means independent because your total is not changing. So here we're going to have 8 plus 5. So there's 13 total cans in there. Okay, and then 8 of them are a regular soft drink. So Julio's going to reach in. There's an 8 and 13 chance that he draws out a regular soft drink. He's like, nope, don't really want this. He puts it back in. So since he puts it back in, there's still 13 different cans in there, and 8 of them are still regular soft drinks. So now we're going to multiply straight across. So we're going to do 8 times 8, which is 64, 13 times 13, which is 169. Then you can go ahead and divide those two out. 64 divided by 169 is going to be 0.379. So that's your final answer for number 5. So let's take a look at number 6. 3 cards are drawn from a standard deck of cards without replacement. So that's another huge word indicator. If we're not putting those cards back, they have to be dependent events because our total is going to be changing. So we're not putting cards back. So we want to find the probability of drawing a heart, another heart, and a spade in that order. So think back to your decks of cards. Pull out the notes 4 if you need to, where it has all of the probability stuff along with the cards, okay? So we want to find the probability of drawing a heart. So I know that there's 52 total cards in a deck. A heart is one of the suits. So since it's one of the suits, there's going to be 13 of them. So 13 out of the 52 cards is a heart. So I draw it out and I get a heart. So I'm going to get a heart and I'm going to set it aside. Well, since I set it aside, now there's only 51. Now let's say I drew and I didn't get a heart. Well, then I would just stop because the probability I'm looking for is done. So we're going to assume that each one are going to be true as we move on. So 13 out of 52. Okay, then we want to find the probability of drawing another heart. Well, we assumed that the first one we drew was a heart, which means there's actually one less heart in there as well. And now we want to find the probability of drawing a spade. So we have one less than the spade, which is going to be 50. So then when we want to figure out the number of spades, there's still 13 spades in the deck. We didn't take out any spades. Okay, so now we're going to do 13 times 12 times 13. And when you multiply across and you do that, you're going to get 2,028. And now we're going to multiply across the bottom. 52 times 51 times 50, 132,600. So then you're going to divide that out and you're going to get 0.015. So that's the probability of that exact situation occurring. Let's take a look at number 7. It says there are 3 miniature chocolate bars and 5 peanut butter cups in a candy dish. Liz chooses 2 of them at random to eat. What is the probability that she chooses 2 mini chocolate bars? Now let's just think about this logically. If you take out a candy bar, you're gonna eat it. That's just how chocolate works, okay? So this is going to be dependent, because the total is going to be going down because we're not replacing. So we're starting off and we have 3 plus 5, so there's 8 total candies in the dishes. And we want to figure out the probability of 2 miniature chocolate bars. Well, to start off with, 3 of the 8 are miniature chocolate bars. And now Liz is going to take one out and she's going to eat it. So then it's going to go down even further. So now instead of having 8 in there, we only have 7. And we also know that she took out a chocolate bar, so now we only have 2. So now let's go ahead and multiply 3 times 2, which is 6. 8 times 7 is going to be 56. So now we just need to do 6 divided by 56, and that's going to give you 0.107. So that's your final answer for number 7. Let's take a look at number 8. In the state lottery game, each of the 3 cages contains 10 numbered balls. The balls are each labeled with the digits 0 through 9. What is the probability that the first 2 balls drawn will be even and that the third will be prime? Well, let's think about this logically, right? If we're drawing the balls out, once we draw a number, we're not going to put it back in. So this is going to be a dependent event because our total is going to be changing. So to start off with, when you have digits 0 through 9, that's actually 10 digits when you count 0. So there's 10 total numbers that can be chosen. Well, how many of them are even? Okay, half of them. 0 is actually an even number. So we have 0, 2, 4, 6, and 8. So we have 5 even numbers. And now we know we're going to take one out, and that's going to be 9. And then the next would be even, so then we're going to draw out another even number, so that will be 4. Okay, now we want to figure out the probability that it will be prime. So we're going to put an 8 down here. The prime numbers 2, 3, 5, and 7. Okay, so we have here 1, 2, 3, 4 possibilities. Okay, so now what we're going to do is we're going to multiply 5 times 4 times 4 across the top, and we're going to get 80. 10 times 9 times 8 on the bottom, and we're going to get 720. So now we're going to divide those out, and we get 0.111. So there's only about 11% chance of that occurring. Next, let's take a look at number 9. Number 9 asks us to find the probability of drawing 3 cards of the same suit without replacement. So when we first draw, it doesn't matter what card we pick. So really, we have the whole deck that could be considered a success. So for the first probability, it's actually going to be 52 over 52 because it doesn't matter what card we take out. Since we're not replacing it, it's going to be a dependent event. So we take a card out, and it's going to be a 51 now because we took a card out. So let's say we draw a card, and it happens to be a heart. So that means now we've taken a heart out. So this, now there's only 12 hearts left in the deck because there were originally 13, but we took one out here. Then we're going to do the same thing again. So we're going to have one less here as well as one less here. So now we're going to go ahead and multiply across the top. 52 times 12 times 11 is 6,864. 52 times 51 times 50 is 132,600. Divide those out and you get 0.052. Put my decimal in my box. There we go. All right, let's take a look at the last one. A cage contains 3 white and 6 brown hamsters. Maggie randomly selects one and puts it back. So that puts it back is huge. That automatically tells me it's going to be an independent event. What is the probability that both the selections were white? So we have 6 brown, and 3 white hamsters. So that means there's 9 total hamsters. That is a long 9. Okay? Then only 3 of them are white. So she's going to reach in, see that it's a white one. Okay, now I'm going to put it back. So there's still 9 in there, and there's still 3 white hamsters. So 3 times 3 is 9, and 9 times 9 is 81. 9 divided by 81 is 0.111. All right, so that concludes your note video for today. Thank you for listening, and let me know if you have any questions.